Hello, PreCalc. This is the after class on Monday, the 9th. So we are looking at this on the 9th, and we are learning how to multiply and divide complex numbers. We've been working recently with numbers complex in the fact that they have a real part and an imaginary part. So here's an example. I call this complex number Z. Is that showing up? It's kind of bright right there. Let me pull it in and move it over. All right, Z is the name of my complex number, and it's my first complex number. I'll call it Z sub 1 equals, there's a number outside the parentheses. That's the magnitude of the complex number, the distance from the origin, and then this is the angle that the complex number makes with the positive x-axis, which is now the real axis. So we have radius times cosine times the angle plus I times the sine of the angle, and these angles are the same always. So say we have that complex number, and let's go ahead and call this r sub 1, cosine theta sub 1, sine theta sub 1. Now I'm going to introduce a second complex number. So it's a different r, perhaps, could be the same, but r sub 2 cosine theta sub 2 plus I sine theta sub 2. So I have, in theory, two different complex numbers, and we're going to develop a way to multiply them quickly. And then we'll talk about dividing them. So let's say that we are multiplying these two numbers together. So we're going to get Z1 times Z2 is going to be multiplying Z1 times Z2. It's going to be multiplying these together and this times each other, this times this. So we have R1 times R2, and then I have this part of the complex number times this part. So we're going to have to do it long ways, but we'll do it only one time, and then we'll see the shortcut that will make us very happy and get through our work very quickly. So first we have first times the first. So I have R1, R2 times cosine theta, cosine theta sub 1 times cosine theta sub 2. So now I'll multiply this times this, and I get plus cosine theta sub 1 times I sine theta sub 2. All right, two more steps left. So I have this times that. So I have plus I sine theta cos sub 1 times cosine theta sub 2. And then lastly this times this. And then I get an I times an I, which is an I squared. Let me write this term underneath. I'm not going to fit it on. So I'll drop down a little bit. Plus I squared, this term times this term. We have I times I, and sine theta 1 times sine theta 2. Alright, so that's my four terms. So let's combine them and observe how easy it can look. Right, now what I'm going to do, I'm going to take this part and the parts without i's. This part right here, do you recall from your imaginary numbers in Algebra 2, what I squared equals? Well, I, we mentioned the other day, is the square root of minus 1. But I squared will square the square root and just give you what's left, the minus 1. So this right here is a minus 1. So I'll just represent it with a minus sign. And now I'm going to gather my terms that have no i's in them. So there's an I here, and there's an I here. But there is no I in this term, so I'm going to grab that, and this term, so I'm going to grab that. And I put them together. And now the terms with I, I'm going to grab this term, and I'm going to pull out, factor out the I, and put it out in front, and this term. So I put, when I factored out the I, what is left? Cosine theta sub 1, sine theta sub 2, cosine theta sub 1, sine theta sub 2, and this term, what's left when I factor out the I, sine theta sub 1, cosine theta sub 2. So I have these left. It doesn't matter which order, because it's added. All right, so do you recognize what has happened here? What is cosine A cosine B minus sine A sine B? You had to memorize that pretty recently. Does it ring a bell? Cosine A cosine B minus sine A sine B. That is the cosine of A plus B. So I went ahead and wrote that right here, and I used the trig ID. It's called a sum or difference trig ID. So it was the cosine of A plus B. And let's see if you recognize this one. This is sine A cosine B plus cosine A sine B. And you memorized that recently. And that was the sine of A plus B. So, and then there's an I in the problem. So do you see these trig IDs are recognizable, and when we substitute them into the when we use substitution and put those in, that becomes a much simpler expression. So here's the pattern. When you multiply two complex numbers, here's the two that we started with. First you multiply the magnitudes. So here that shows up R1, R2. Then you take the cosine of the sum of the angles. So you're going to take the cosine of theta 1 plus theta 2, and then I sine of the sum of those two angles, theta 1 plus theta 2. All right, so that is quite doable, and we'll do one in a minute. I'm not going to go through the same development, although we could in the same way. It will show up that if you divide two complex numbers, z1 and z2, the same complex numbers that we started here, if we divide this by this, it turns out that the formula for that could be developed just like we did with multiplication. So you get R1 divided by R2, and you have cosine of theta minus theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So notice multiplication involved adding the angles in the arguments, and division involves subtracting the arguments. All right, let's do one. Let's say that z1 is this complex number. Its magnitude, its distance from the origin, is 2. So if we were graphing it, we would be at 2 pi over 3, which is 6/4 pi. So we would find it by counting our 6. 1 6, 2 6, 3 6, 4 6. 4 6 pi is right there. And it is 2 away from the origin. So we have a picture of it. And then we're going to multiply that by this one. And that is at 11/6 pi, which is way over here, and it's 8. 2, 4, 6, 8. It's a long, daddy long legs here. So we have 8 that is at this angle, 11 pi over 6. So we're going to multiply these two vectors. And the whole reason that we learned about complex numbers in trig form is so we can multiply them so easily. Otherwise, we have to do it the long way, which involves lots of steps and lots of grief. So we decide to be much more joyful and do it the shortcut way, but the numbers have to be in complex form to use this formula. So as the formula states, we multiply the magnitudes together, 2 times 8, and then we're going to take the cosine right here and add the two angles. So we're going to take 2 pi over 3 plus 11 pi over 6. So let's get that started. All right, so we multiply the two together. So we're going to give myself some room to write. Camera and paper. All right, so we're going to multiply the two together and get 16 cosine, and according to the formula up here, I'm going to add the two angles. The two angles are this angle and this angle. So I'm going to get 2 pi over 3 plus 11 pi over 6 plus, and now I go I sine, and again the sum, same sum. All right, so simplifying, we're going to get the 16, and this is really 4 pi over 6. So combining 4 pi over 6 and 11 pi over 6, I get 15 pi over 6. And I sine of the same. Alright, 15 pi over 6 is a little awkward because it's more than one time around the unit circle. So I will go ahead and figure out what that is, and then I'll check the book. I'm trying to check it now, but I can't see it. It's over here in a dark corner. So let's improve on this 15 pi over 6. So if I go back to my circle here, I was putting in the sixths. So 1, 6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6 pi. And we're going to 15, 13, 14, 15, 6 pi. Took me right there. So what's another name for that? It is pi over 2. So I want to use the reduced simplest form. So I get pi over 2, which is the same as 15 pi over 6. But do not let this angle be greater than 2 pi. You will be able to simplify it if it is. Alright, so let's look at the cosine of pi over 2. So we have our circle going here. Right here, that is the coordinate 0, 1. 0 to the right and left, 1 up. So let's actually find out what is the cosine of pi over 2. It's the first coordinate, 0. And what is sine of pi over 2? It is 1. So we end up all together with 16 times 0 plus 1, which is 16. So believe it or not, this, where did the problem start? This complex number times this complex number gives us a 16. Although I lost something, didn't I? I'm sorry, it's not quite right. Right here, there's an I that I lost. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1, but I left the I out. So there's really an I here. So I don't have to really write the 1I or I1, so I can just write that as I. And so I end up with 16 times 0 plus I, which is 16I. All right, that is the final answer to this problem. This times this is 16I. All right, if I was to graph 16I, I would go in the I direction. I'm sorry, the I direction. This is the reals, this is the imaginaries. If we're on a coordinate plane, I'll draw it separately because it's not like a unit circle. So we have reals and imaginaries. It would be going up to 16. So say that's worth 4, 8, 12, 16I. That would be the answer to that problem. All right, we'll finish by looking at Z1 divided by Z2. So we'll get started on that. Same problem, except I'm going to divide these two numbers instead of multiplying them. I'm going to use this principle. I divide the magnitudes and subtract the angles. All right, so dividing the magnitudes, I'm going to get 2 over 8. And subtracting the angles, I get cosine of, what was the first angle? 2 pi over 3 minus 11 pi over 6. And same for the sine part, I sine part. All right, so now that is the answer to the division. Let's clean it up a bit. This is 1/4. Pi, 2 pi over 3, we discussed earlier, was 4 pi over 6. 4 pi over 6 minus 11 pi over 6 gives me minus 7 pi over 6. Lost my cosine. So now we have cosine of minus 11 pi, not 11, it was 4 minus 11, so that's minus 7 pi over 6, and I sine minus 7 pi over 6. All right, let's take it, let's look where is negative 7 pi over 6. If I go up here to that unit circle, negative 1, 6 pi, 2, 6 pi, 3, 6 pi, 4, 6 pi, 5, 6, and I'm looking for 7, 6. So negative direction. So here's where I ended up, right here. And that is in the positive direction, is the same as 1, 2, 3, 4, 5, 6 pi. So this is 5 pi over 6. So I can change this minus 7 pi over 6 to a positive 5 pi over the 6 because they're the same spot. And now I take the cosine. Remember at this point we went back square root of 3 over 2 and up 1/2. So there's the coordinates. So cosine is the first. So I'm going to get this value 1/4. And when I get in here and take the cosine of 5 pi over 6, I'm going to get negative square root of 3 over 2. And then I won't forget my I this time, plus I. And the sine of 5 pi over 6 is 1/2. All right, so I multiply these values by 1/4 and simplify if I can. Let me just put it up here, kind of ran out here. 1/4 times negative square root of 3 over 2 is negative square root of 3 over 8 plus I. And 1/4 times 1/2 is 1/8. All right, So here we have our answer, negative square root of 3 over 8 plus 1/8 I. I'll put the I on the other side to be conventional. So this is the answer in standard form. This is in the A plus BI form. It is a standard form. Some problems will ask you to do the standard form, and some will ask you to leave it back here in the trig form. So, all right, that is how you multiply and divide complex numbers in trig form. So, not many people in the world, in the whole world, where's my world? All right, not many people in this whole world know how to multiply and divide complex numbers in trig form. All right, till tomorrow when we will practice these. I think you'll find they go quickly and they're short and sweet. All right, till then, bye.